So number 52, we have a rectangular loop carrying a current lies in the plane of a uniform magnetic field of magnitude 0.04 teslas. The loop consists of a single turn of flexible wire that is wrapped around a flexible mount so the dimensions of the rectangle have been changed. However, the total length is not. As edge length x is varied from approximately 0 to a maximum value of 4 centimeters, the magnitude of the torque on the loop changes. The maximum value of torque is approximately that. What's the current in the loop? So here's the issue. I think they mean that x can be measured anywhere between here, if you stretch it this way, where it's almost 0, all the way over to, going the wrong way, to this way where you can actually reach 4 centimeters. If that's the case, the total length of this wire must be approximately 8 centimeters. So I'm going to make that assumption. So to answer this next one, how do you get the maximum torque? Well, in this case, n is 1. Current's what we're looking for. Magnetic field's constant. We need to maximize the area. But how do you get the maximum area? And some of you might have guessed already, but let me just walk you through this. The area would be given by this. So again, reminder, if this thing has a total length of, if L is 8 centimeters, and I'm going to do it in terms of variables first. If both these sides are L and the total length of this thing is L, then the area would be given by x times this distance here, which if you work it out real quick is going to be the total length of the wire minus the 2x due to the two edges, divided by 2 to give us whatever this distance is here. And so the area then is going to be x times this distance, which is given by that fraction. Multiplying that out, the area now is equal to this, xl minus 2x squared over 2. How do we figure out when it's a maximum? Well, as we move from this to this, the area curve goes from minimum to a maximum back down to a minimum if you graphed area versus x. And the question is, when do you get maximum? Well, just a quick note on this one. Again, you can sort of realize, oh wait, I just need to figure out at the peak here, the slope is 0. I define the slope, I'm going to take the derivative of this expression with respect to x. And if you do that, you just simply end up with L over 2 minus 2x is the slope of this graph at any given point. To find out when the slope is 0, I'm going to set that equal to 0, rearranging that, and logically enough, as you might have guessed, you'll get a maximum when x is equal to the total length divided by 4. In other words, when this thing is a square. In other words, when it's 2 by 2 by 2 by 2 centimeters, or the area is going to be given by that. We can now plug that into our equation over here. We know the torque is given by this expression. So plug that in over here. N is going to be 1, so I just dropped it, times the current we're trying to find, times the area, which is what we just found. And the magnetic field, it was given to us somewhere up here. There it is, 0.04 teslas, plugging in down here. And if you solve that, you'll get the current is 0.003 amps or 3 milliamps or 3 times 10 to the minus third amps. Hopefully that makes sense. Good luck.